Good morning, everyone. I'm audible.
Good morning. Yes, madam, you're audible.
Okay, thank you. So, hello, everyone. Dear authors and invited guests, welcome to Technical Session 10B. I am Rajnandini Patil, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, Pune, India. The 10th edition of the conference is being organized in hybrid mode. The physical event is held today in Pune and the virtual event is being held through Zoom from 19 to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce all to the chair for this session. Dr. Sopan Talekar. Dr. Sopan Talekar is currently working as Associate Professor at Karamveer Advocate Baburao Ganpatrao Thakre College of Engineering, Nashik, India. He has published and presented more than 10 research papers in reputed journals and conferences such as IEEE, ACM, and Springer. He is also the author of two books on artificial intelligence prescribed for Pune University and Gujarat Technological University. His areas of specialization include cognitive radio networks and bandwidth estimation in wireless network. Welcome to the session, sir.
Thank you, ma'am.
So now let's start with our first research paper. For this, I would like to call Valli Vishwavarshini for the paper title AI IoT Integrated Vital and Behavioral Monitoring System for Astronauts and Elderly in Offline Environment. I kindly request the presenter to start with the presentation.
Yes, ma'am. Good morning, ma'am.
Yeah, good morning. You can start with your presentation.
Yeah. So good morning, everyone. I'm Valli Vishwabhashini from St. Joseph College of Engineering, and today I'll be sharing the idea behind my work on AI IoT integrated vital and behavioral monitoring system for astronauts and elderly people in offline environment. So at a high level, this work looks at health monitoring in situations where people are physically isolated. Two very different groups face this problem. Astronauts on long missions and elderly people live independently. In both cases, continuous monitoring becomes difficult because most existing solutions assume internet access or constant human supervision. So the idea here is to build a system that can observe vitals and behavior locally, make decisions on its own, and alert when someone or something abnormal happens to the person over there without depending on any internet access or cloud environments. So today, many elderly individuals are not living alone by choice, but by the changing social and economical conditions. Work-driven migration, nuclear families, and lifestyle changes often push elderly people into situations where they must manage their daily life and health without any immediate support. Astronauts, too, face a similar kind of issues in a very different context. They operate inside confined spacecraft for long durations with delayed or limited external intervention. So in both cases, if something goes wrong, Waiting for a human assistance is not always an option. So that is why we need a system that can observe, reason, and respond autonomously. So with the objectives, the main motivation of this is the goal was not to build a single sensor or a single module. Instead, the objective was to design a system level framework that can monitor health from multiple perspectives, both behavioral and physical. The focus is on offline operation rather than depending on the internet, and to ensure low cost and wearable independent deployment so that the system remains practical even in constrained environments. Privacy is also a key consideration since all process happens locally. So when we look into the existing systems, as said, continuously rely on the cloud connectivity and data analysis. And when we consider wearable-based solutions, it needs frequent charging and high user compliance and all those. And for elderly peoples, like for them to depend on the technology, like they have no kind of idea on the technological side. And in space missions, health data is usually transmitted through telemetry, which introduces delays, which cannot be a constraint in this case. So these limitations mean that the existing system are not designed for real-time response in offline or isolated conditions, which is an exact gap this work addresses. So the system that we propose is to address these gaps is a hybrid AI IoT framework that combines physiological monitoring with behavioral analysis. The idea is very simple. Instead of relying on a single signal, the system looks at how the body behaves, how the person moves, and how they appear emotionally. All of this happens on an edge device so that the data is processed in an edge device where there is no need for a cloud dependency. And real time and privacy, everything is enabled so that everything is processed in edge device without any need for cloud environments. This makes the framework suitable for both space missions and elderly care scenarios. So this is my idea of the front-end architecture. So which is responsible for data acquisition. So at this stage, the system observes the individual through two primary sources, physiological sensors and a camera. The sensors captures vital signs such as heart rate, where the camera continuously observes the facial expression and body posture. What is important here is that no raw data is sent to the cloud. All the inputs are forwarded directly to an edge device, which acts as a local intelligence unit. This system ensures that monitoring continues even in offline or delayed communication environments, which is critical for both elderly care and space missions. And here we have Arduino board and or ESP3 modules that we use. So all of this can be used in offline environments without need for any internet connectivity. So that is the main idea with the front-end architecture. And when it comes to the backend architecture, this is the diagram that shows the system process data inside the edge device. Once the input arrives, so as said, we have three modules. One is the IoT module that gets the user input like vitals and everything. Then second is the facial emotion recognition module that recognizes the facial expressions of the person. And then the third one is the posture. So to detect any fall of the if the person is falling or not. And we have a fusion layer that has gets all the data and fuses it and then sends to the backend to process it all over. These analyses happen in parallel, which allows the system to respond quickly rather than sequentially waiting for results. The output from all the modules are then evaluated together to understand the overall health context. And then if a potential risk is detected, the system immediately generates an alert and records the observations locally. So the core modules in this project is first, we have three core modules. First is the posture and fall monitoring module, which identifies the unsafe movement patterns or falls risks. which are especially crucial and critical for elderly individuals. And second is the facial emotion module that provides insight into stress and fatigue, which are early indicators of both physical and mental strain. And the third is the vital sign monitoring tracks that tracks the psychological changes as like not cycle it tracks the heart rate and physiological variations of a human body, and by observing all these three the system gives a more complex understanding of a person's condition than any other single method. Like combining all these three would be an efficient method rather than these having these as a single methods. So the results over here is like through the prototype level validation, the system demonstrated the ability to monitor health indicators in real time, even without internet connectivity. So the base idea is like having a trained ML model at the backend for to deploy it without internet. So that was the main idea. And combining multiple signals helped improve the reliability of detection and reduce false alerts. Overall, the results show that the framework is feasible and efficient for isolated and resource constrained environments. For the future enhancements, additional physiological sensors can be integrated to enrich diagnostics, like SpO2, temperature, and GSR sensors. Edge processing can be further optimized, and mobile interfaces can be developed for caregivers or mission teams. Beyond elderly care and space missions, this framework can also be adapted to other high risk domains. So, to conclude, this work focuses on designing an autonomous AI IoT integrated health monitoring framework for environments where human supervision is limited. By combining psychological and physiological and behavioral indicators and processing them locally, the system supports early detection and timely response. The framework is applicable to both astronaut health monitoring and independent elderly care, addressing a growing real world need. Thank you for your time and
So thank you, Valli. Sir, you can proceed with the questions.
Yes, thank you, ma'am. It was a nice presentation. I would like to
thank you.
ask one question from this. Yeah, I'm audible now.
Yes, sir. Yes, sir.
Okay. So in your presentation, you have used the age-based devices, right? So
Yes.
what would be the limitations of the age-based devices by considering the constraint like limited computations or the energy efficiency? How your concept is going to deal with such limitations?
Hello, sir.
Yes. You
Like,
got my questions?
yeah, sir. Like, can you repeat? I think I'm having some.
Yes. In your architecture, you have shown the age-based devices that were used, right?
Yes, sir.
So
Yes.
yeah, so what would be the limitations in general for the the age-based devices, and how your system is going to deal with such a limitations?
Okay,
Like
sir. So,
limited computations or energy efficiency in that case. You mentioned ki, it is energy efficient, but how it would be?
okay, so like you're asking about the edge-based devices when there is a limitations in it, right?
Right.
So yeah, sir. For this, what I'm planning is like limited computation resources, like uh, on edge devices, we can limit it for a certain period of time. I think, sir. I'm not much about like I've not worked in the edge-based system. I'm still learning it, but the key idea is like we'll have a restricted memory or storage for it
Right. Mm.
for the
So
edge-based devices and
yeah. So whatever the that the limited the resources which we have with the edge-based devices. So your system is that key these resources are enough to your system. Have you analyzed it?
no, sir, I'm still working on the that part of analysis.
Oh,
So this was a
okay.
base idea.
Okay.
On the implementation part, I'm still working on.
Okay. Analysis is not mentioned in your paper, right?
Yes, sir. Yes.
Okay. Okay, thank you, madam.
Yes, sir. Thank you, sir.
So thank you, Ali. Can you please share your presentation? Okay.
Yes, ma'am.
So for the next presentation, I would like to call Debyendu for the paper title Digital Retailing Through Smart Technologies, Understanding Consumer Purchase Behavior from an ICT Perspective. I kindly request the presenter to start with the presentation.
Thank you, madam. Am I audible?
Yes, you're audible.
Good morning to everyone, and thank you for the opportunity. Now, today I going to present my work. The topic is digital retailing through smart technologies, understanding consumer purchase behavior from an ICT perspective. Authored by Dr. Urnangshu Giri, Dipanita Chakraborty, Dibyendu Roth, Mahadev Bera, and Sunandita Udhigari. And myself, Dibyendu Roth, I am presenting our team, our work. Recent days, actually, in big data, cloud computing, uh, all are very much influencing in retail industries. Actually, in retail industries, the small quantities of product has been sold by the retailer. Actually, physically, the retailer sell the items, but in recent days, ICT has a influence, or the retailer they prefer ICT based applications for the retailing, or for growing the interest among the consumer end. So ICT tools not only help the retailer engage customer, but actually they maintain the relationship between the customer and retailer, and achieving the competitive advantage in recent time. So from the literature, we basically find out some research gap. The first one is the unclear role of ICT in improving the performance of retail industry, and second, how the growing trust issues regarding the application of ICT in retail domain and can be resolved, and third, the problem of over information in the digital platform. Actually, sometimes the consumer they are confused regarding the over information, and they also feel dilemma at the time of purchase. So our objective of the study is to study the factors are responsible to judge the review comment about a particular product in the online platform, to study how review balance influence the consumer decision making. Now, from the conceptual background literature review, we are basically fixed some hypotheses. So these four hypotheses basically generated. So in first this is our research model. So here there are five factors to actually. So first, social impact of ICT, and ICT generated information quality, perceived risk, and review balance. So basically, with the review balance, the social impact is positively related, and ICT generated influence qualities positively, and perceived risk, which is basically increase the anxiety level of the consumer to purchase a product, that is negatively affect the review balance. And uh, the review balance directly positively related with the purchase intention. So basically, ELM model, basically elaboration likelihood model, is explained the research model. So this model is explained how an individual who can align to really relevant quality information gets strongly motivated by the information processing and follow the central route. ELM also shows the consumer may get influenced by the social group, or any may get influenced by their logical reduction based on the information available in the digital platform. So social influencer or social advertisement basically influence the consumer. So social group recommendation also influence the customer, which is increase the review valence. And other side, the many kind of information likely ICT generated information, which is also increase the interest level or increase the review valence towards the customer. And lastly, the perceived risk basically generates from the many types of comments or negative comments which is available in many apps, so which basically decrease the interest level of review balance. So if the perceived risk decreases, then review balance will be increased. So here four hypothesis is social influence through ICT has positively correlate with the review balance, and ICT generated information quality has a positive correlation with review balance, and perceived risks has a negative correlation with the review balance. Review balance has a positive correlation with purchase interest. So this is our research model, and here clearly shows all hypotheses and the relation. So now we are doing qualitative as well as quantitative analysis. So in quantitative analysis, we are prefer our online cross-sectional survey and our descriptive research design. And here we choose the age group 18 to 65 years between, and total 403 Indian respondent here participated in our survey. And we use the convenience sampling method. And the period of the survey during the July 2024 to September 2024, 2024. And we are using Likert 5 Likert scale, 5-point Likert scale model, where 5 is strongly agree and 1 is strongly disagree. So this is the clear this is the clear gender, male and female percentage, and age group. So basically less than 20, 20 to 40, and 40 to 60, and above 60 number of respondent and their percentage. And there are PG, above PG, and UG level of UG and 12 standard educational qualification people are was responding, and their income level also. Now uh, now in next level, in qualitative analysis, we basically use the in vivo software for highlighting the model keywords or the model variables, which is clearly shown here. Actually, this software highlights those parameters or those variable which basically used in model. So these are social impact of ICT here clearly. So social impact, perceived risk, and the review balance and the purchase interest, all are highlighted through this analysis. And this is the reliability and validity test of our collected data. So actually we calculated the critical relativity, AVE, average variance extracted, and MSB, maximum shared variance, and ASB, average shared variance. So average shared square variance. So here we clearly seen that the CR value for all variables is above, all hypothesis is above 0.7, which is the threshold limit. Above the 0.7, which is the limit, it should be above 0.7. And AVG value, it should be above 0.5. So here in all variable, it comes above 0.5. And AVE value greater than the MSB and ASB value. So it is clearly shown that the all value is greater than MSV and ASV. So it clearly shown the internal reliability here, shown the internal reliability, and convergent validity shown through the AVE. And in next table we clearly seen the root of AVE value, which is which basically construct the relation between the own. So this value says that the all these variables are independent and discriminated. So in next structural hypothesis testing model, so here the beta value and p value all are in between the significance level. So we can say the our hypothesis, all four hypotheses is significant, and they are established from the statistical value. So from the statistical analysis, we can conclude, or we can find that the all hypotheses H1, H2, H3, and H4 all are established the relationship among the variables. And this study shows the how ICT can take a critical role to into the purchase interest of the consumer in retail sector. So in implication, basically this model or this can be implicated very implicable in retail industries. The manager of retail industries can use it for to understand the behavioral pattern of the customer. The retail manager can focus on their reduce the perceived risk among the customer and increase the trust issue between the customer. An adaptable ICD system can help retailer to improve their customized recommendation through interacting with the users, and it is also effective for recommender system or feedback system of the customer. And it also uh, reduce the fake and social harmful reviews or identification or system which increase the customer review balance and customer purchase interest in retail product through ICT or online app. So we can conclude that the ELM, that means elaboration likelihood model, which is peripheral and centric Q, it helps the psychological backdrop purchase decision making. And this all hypotheses have confirmed that review balance strength purchase interest while perceived risks obstruct it. So finally, we can say the model clearly indicate or clearly suggested that through the ICT, the customer or the consumer purchase interest is continually increasing in day to day, and the retail industry so also use the ICT application or ICT platform for using their growth. These are the references from where the total model and the analysis has been done. Thank you.
Thank you, Debendu. Sir, you can proceed with the questions.
Okay. Yes, I have gone through your presentation, and in which you have mentioned the result analysis, including quantity and qualitative analysis. My question is there, if we consider some artificial intelligence or big data analytics technologies, so how such a smart technology that will influence the consumer purchase behavior? If we talk about the digital retailing from an ICT perspective.
Sir, can you repeat once
Yes,
your
yes.
question?
Yeah, you have collected the data and you have performed the analysis quantitative and qualitative, right?
Hmm.
Right.
Yes.
So yeah. So if we if we use the smart technology like artificial intelligence or data analytics techniques, right,
Mm-hmm.
to get the conclusion of such a things that will definitely helpful to influence the consumer purchase behavior, right?
Right.
So right. So how such a technology will be that make a difference from the traditional technology like quantitative and qualitative analysis. Of course, you have done the quantitative and qualitative analysis with limited data, right?
Right. Right.
So if
403 data actually we
right,
have been
right.
collected. Yes.
And if you have the big data, and then you are going to perform the analysis using the artificial intelligence, right, or big data analytics, so the result will be the different because when you do the analysis on small chunk of data and when you do the analysis on the large amount of the data, obviously the result would be the different, right?
Yes.
So
Actually, we mention in model, we mention actually perceived risk. At the time of data, we face some challenges regarding perceived risk because some of the consumer or customer, they are demotivated from the negative comments or from the technology anxiety, this kind of thing, or so we mention a negative relation which is basically demotivated the interest of purchase interest of the customer actually. If But our data is that was our one limitation, that our data is very small, 403, where the population is huge. So actually using big data was something uh, uh, it may be artificial intelligence, it may be showing, but according to the uh, according to our analysis, the result shows that uh, purchase interest through is increasing continuously through this ICT perspective.
okay, yes, that's from my side.
Okay, so thank you, Debyendu. Can you please unshare your presentation?
Thank you, ma'am.
So for the next presentation, I would like to call Amanda for the paper title Exploring Robotic Support as Tool for Emotional Regulation in Children with ADHD. I kindly request the presenter to start with the presentation. Amanda, you there in the meet?
Can you see my presentation?
Yeah, we can see your presentation. And it's humble
Okay, thank
request
you.
for everyone to complete your presentation within the given time limit. Please don't exceed that.
Okay. Good morning, everyone. I am honored to present our research exploring robotic support as a tool for emotional regulation in children with ADHD. This project represents a multidisciplinary effort between telecommunications engineers and special education experts to bridge the gap between social robotics and psychological therapy. So, what is the core challenge we are addressing? ADHD affects approximately 5 to 7% of school-aged children. Beyond the well-known symptoms of inattention, hyperactivity, and impulsivity, these children often struggle with emotional burden like frustration, irritability, and low self-esteem, and social isolation. Traditional therapies are effective, but generalizing these skills to everyday life remains a significant hurdle. So, we believe robotic mediators can provide the missing link. And to address these needs, we developed a robotic assistant which focused on enhancing the recognition, understanding, and management of emotions through play-based interactions. Technically, the system is powered by a Raspberry Pi 4
that manages high-level logic and communication. And for movement, we utilize 11 servo motors, providing 12 freedom degrees across the head, arms, wrists, and hips. This allows for a wide range of human-like gestures, and the interface includes an LED screen to display facial expressions and integrated speakers for synchronized auditory feedback. I think it is important to mention that to guarantee a safe and effective interaction, the robot is programmed in polynomial regression equations for each of its joints, which ensures its gestures and smooth, natural, and predictable for the child. This mechanical fluidity is complemented by a strict multimodal synchronization where dynamic facial expressions and the LED screen emitted sounds and body movements act in concordance. In this way, we ensure that emotions are easily identifiable for the participants. Our study involved 7 participants with an average age of 9 who were already receiving psychological support for emotional regulation. And to evaluate their progress, we applied 2 projective tests, the Roberto and Rosita test and the Under the Rain graphic test. In the first test, Roberto and Rosita are presented as 2 characters so that the children can build an entire story around them, which allows us to explore their personal perceptions of family and social bonds. The Under the Rain test specifically examines their coping strategies and resilience in stressful situations. It is important to mention that every narrative and drawing was evaluated by an expert ADHD therapist who analyzed technical indicators such as body posture, color choice, and protective elements like umbrellas to establish a comprehensive emotional profile for a child and track their clinical progress. Okay, the robot was programmed to display the 6 basic emotions: happiness, sadness, surprise, fear, disgust, and anger. For a child with ADHD, human social cues can be overwhelming or inconsistent. A robot provides clear and consistent non-verbal signals, making it an ideal, not judgmental platform for teaching emotional decodification without the social pressure of human interaction. Okay, so how did we utilize the robot across the 10 sessions? In session 1, the robot acted as a social icebreaker, greeting children and maintaining attention during initial assessments. In session 2 and 3, it became a storyteller using expressive tones and facial cues to help children name their feelings. During sessions 4 to 7, this was the core of regulation because the robot modeled deep breathing routines and counting exercises, suggesting calming keywords during role-play games. In session 8, it introduced metacognition through a thought journal, showing children how to record and manage daily events. And finally, in sessions 9 and 10, it provided a calm, standardized environment for the final evaluations. In the Roberto and Rosita test results, our expert observed a clear transition from pre-intervention narrative centered Participant 7 described a character using night reading as a strategy to stay calm and manage emotions, reflecting the a direct application of the skills learned. And 6 out of 7 children showed improved academic motivation and a marked increase in self-confidence, expressing pride in their new ability to handle social challenges. In the Under the Rain drawings provided the most visual proof of growth, as the expert identified a systematic shift from passive vulnerability towards internal resilience. Pre-intervention drawings often showed direct exposure to rain with no protection. For example, participant 4 drew a sad expression with lightning and no umbrella, while participant 5 used muted colors to represent a girl alone. However, post-test drawings reflected a move towards harmony and well-being stimulated by the robot's influence. We saw participant 1 add hearts and flowers. Participant 3 included a dog and the sun to show gratitude for their bond, and participant 4 draw a smiling child with the value be respectful. Most notably, participant 7 transitioned from an isolated individual focus to drawing 3 connected figures. These specific symbols were the sun, pets, and family connections, and they serve as strong indicators of newfound optimism and security achieved through the intervention. Our findings reinforce that robotic efficacy lies in the robot's ability to maintain high levels of attention and provide controlled and predictable feedback. The robot acts as an effective mediating tool, allowing us to teach adaptive behaviors tailored to the specific developmental needs of each child. And by acting as the bridge, the robot helps children practice regulation in a safe space before they apply it in the real world. Beyond its technical performance, our system is a tool of easily mobilization because it is portable. Design allows it to be easily integrated into different schools or clinical settings, but it is important to recognize the limitations, and I think the main limitations are the small sample, the short duration of the intervention, and the quantity nature of projective test intervention. There is also influence in the novelty effects in the children's response. So larger and longitudinal studies and comparison across robot types are needed. Thank you for your attention.
Yeah, I am audible, ma'am.
Yes, you're audible.
Yes.
Okay. Yeah, it was a nice presentation, and I have gone through it, and it is observed that yes, what type of the data that we have consider, like the age group of the child, if you consider the different age group of the child and different, then how your robots, that it supports their emotions. So is there any difference that you observe?
Could you please write your question because my listening is not the best?
Hello. Hello, I am audible.
Yes, sir, you're audible.
Uh, I just want to ask you ki, the for the emotional regulations and the attention control, the age group of the child does the matter? What's your observations?
Uh, Sorry, but could you write your question, please, in the chat?
Okay. Yeah. I just want to tell you ki, you know that there is a different age group of child, right?
Yep.
Age group of child. So, is there any observations from your side in identifying their emotional
The drawings.
emotions identification with respect to the age group?
Okay, the children's, when they draw, they show, like, for example, sad expressions, uh, the position of people when they draw it, their family. Um, Emotions were identified.
Yeah, I put in chat box also.
Okay.
Amanda, you're not audible.
Okay, we did not rely on children naming emotions with adult level precision. We inferred emotions through developmentally suitable expression channels like narrative stories and how characters feel, react, and resolve conflict. Um, because children at this age often show emotions through behavior and symbols rather than explicit vocabulary. So we focus on observable indicators of affect and coping. Um, yeah.
Yes, ma'am. Thank you.
Thank you.
Thank you, Amanda. Can you please unshare your presentation? Okay. So for the next presentation, I would like to call Amuk for the paper title Interference Mitigation in Coexisting NB-IoT and 5G Networks. I kindly request the presenter to start with the presentation. Amok, are you there in the meet?
Yes, I'm audible.
Yeah, you're audible.
The screen is sharing. You can
Yes,
see
it's
this?
visible.
Yes. Good morning for all. My name is Amok. I'm talking about interference mitigation in coexisting and NB-IoT. Wait a minute. And 5G networks. These are the overview of a project and introduction. This project focuses on the real-world wireless communication problem that occurs when NB-IoT and 5G networks that operate together. As a number of IoT devices increasing in day-to-day life rapidly, so both technologies must share limited spectrum resources. This sharing leads to interference, which negatively affects the sharing of interference, which negatively affects performance of the which we use in day-to-day life. The project aims to study the interference and propose efficient technique to reduce it. So our aim is to improve the reliability, coverage, and overall quality of the service. So these are literature surveys which we have worked on. Hello.
Yes, you're audible.
Literature survey. These are the papers which are related to NB-IoT and 5G coexistence. You can see the papers, and which these are based on NB-IoT and 5G coexistence, interference, and congestion control, random access techniques, and machine learning and reinforcement learning approaches. These are based on this paper. So they have the limitations which we have improved in our projects. These limitations are decentralization, scalable, and privacy preserving approaches, which leads to the proposed IORA and FLORA techniques in our project. The statement: the project focuses on mitigation coexisting channel interference in 5G and NB-IoT coexistence in MMTC in dense urban environments where spectrum scarcity impacts chaos and connectivity. The base paper simulation framework highlights overlap issues, and this works introduce FLORA for privacy preserving decentralization optimization, and IORA for aligning interference in reduced subspaces, aiming to maximize spectral efficiency by SINR wave, ensuring 90% plus NB-IoT device connectivity. So the main goal is to improve the SINR, maximize spectral efficiency, and maintain more than 90% of connectivity for the NB-IoT devices. And our objectives are analyze interference effect, analyze the interference effects using simulations, design interference aware access control techniques, implement IORA and FLORA algorithms, evaluate the performance parameters that are SINR, bandwidth, utilization, transmit power, and coverage, and develop a MATLAB-based simulation framework. Propose solutions suitable for future large-scale IoT networks. These are the basic objectives of the project. And applications where our project is applicable. These are applicable in smart cities and agriculture, healthcare, rural agricultural for sensors and 5G devices, healthcare using NB-IoT sensors and 5G monitoring, industrial IoT, transportation, smart grids, energy monitoring. All these applications involve NB-IoT sensors and 5G connectivity working together, making interference mitigation critical. And this is the functional block of the functional block diagram. As you can see, NB-IoT and 5G device transmit data. Signals passes through the shared wireless channel. Interference occurs due to the overlapping of the spectrums. And IORA and FLORA are the decide when the device is allowed to transmit. The base stations collide learning, aggregation, FLORA, and this evaluate the performance based on the reaction of the interference. And for the final is this is the photo of a data set which I have taken for the project, as you can see. We have generated the virtual data on our own, so we did not get the data set of real time. So we generated our own data set for interference analysis. This is a realistic wireless data set generated following 3GPP standards to analyze interference and SINR performance in cellular network. Our data set has more than 20,000 wireless emission events. Each event contains data type of NB-IoT or 5G networks, distance from the base stations, path loss, received signal power, interference power, SINR. This dataset forms the foundation for analysis and learning-based optimization. These are the formulas and all things we have taken for the dataset generation. As you can see, these are all the formulas we have taken. And next, proposed methodology. We have selected the algorithm, which is called FLORA. IORA and FLORA, interference aware opportunistic random access, and federated learning optimized random access. These are the two algorithm which you have taken for the project. If the IORA only transmits, these are the two conditions. If these conditions are passed, then the transmit of network is possible. Condition number one, SINR, signal to the noise ratio, should be more or equal to the 10 dB. So then only it guarantees the device own link to strong. The link is strong. We can know that the link is strong and the transmit will be efficient and reliable, as you can see. And second condition is interference should be equal to or lesser than ITHI, which ensures the device transmission won't harm neighbors beyond the tolerant level. And dataset generation, we have generated the data, as I said, MATLAB based simulation, as we discussed before. And this method, FLORA framework, NB-IoT and 5G transmissions are simulated under shared spectrum conditions. The model includes each trains are small local ML models. The model includes realistic channel effects, noise, and transmission power constraints. LSTM based temporal predictions. LSTM models, the long short-term memory model, learns the temporal variations in interference, and SINR accurately predicts the safe transmission slots, enhancing IORA and decision-making reduction, packet collision, and performance evaluation for SINR. The LSTM-based prediction use the temporal variations in SINR interference and transmission success. By predicting the future channel conditions, device select the safer transmission times, reduce the packet collision, and improve the quality. And this performance evaluation. System performance is evaluating using SINR, interference power, bandwidth usage, transmit power, and access success probability, which results are compared before and after applying FLORA and IORA. These are the diagrams which we have generated from the MATLAB by applying these algorithms IORA. These all are same diagrams. Means we have run through the different algorithms like FLORA. This is IORA, and this is FLORA using PPO, proximal policy optimization, and using DDGP. As you can see, I will show you the one example. This photo is before applying IORA algorithm. You can see that the interference is more. You can see the beside line which is showing the power. So here the interference is more. After applying IORA algorithm, you can see here the interference is reduced. And this third diagram shows the difference between before applying IORA and after applying IORA. These all are same diagram, and you can see this table where we can conclude that IORA shows the clear improvement in baseline access. As you see that FLORA using PPO has more reduction efficiency comparing all. And the standard and results and discussions. All FLORA approaches reduce interference, and reinforcement learning methods outperform others. PPO provides the best adaptability and performance, and LSTM-based FLORA achieved the modest improvement of 5 dB, 5.808 dB, indicating the temporal learning offers limited but consistent interference suppression compared to RL-based approach. And the conclusion of the project is Iora is simple, reliable, and low cost. Flora provides adaptive privacy preserving optimization. RL-based Flora achieves 30 to 35 dB interference reduction. The approach is suitable for future large-scale IoT deployments. And future works may include multi-cell scenarios, beamforming, power control, and advanced AI models. These are the references. Thank you for your time.
Okay, thank you, Amok. So you can proceed with the questions.
Yes, you can show the result analysis table. Just I want to check. Yeah, this one.
Yes.
Okay, we have used the different algorithms and you have shown
Yes.
their interference before and after using the algorithms. Okay, how much it is actually reduced. So which parameters you have considered for the interference mitigation techniques like power control or spectrum sharing?
These are the parameters, distance and path loss dB. Here, I'm sure you can see the data sets,
Okay.
noise, SINR site,
Okay, dB, that is
SINR
power.
ratio.
Power is also considered. Right.
Yes.
Spectrum sharing is not there, I think, na?
Spectrum sharing. The data set is virtual, so
Okay.
we did
That.
not get realistic real data sets, sir. So we generated on our own,
Okay.
sir. So,
Mhm. Okay. So you
yes.
can extend this work also using the
Yes.
the scheduling work and some spectrum sharing, because
Yes.
when we share the spectrum, so at that time the interference would be there, right? Because
Yes.
when you share the spectrum at the same time, the other users also try to access the spectrum.
Yes.
So spectrum aware the interference reduction that works also you can extend along with this, right?
Yes. We'll extend this.
Okay. Okay.
Our team will be on it.
Yes.
Yes. I
Yeah,
can
next.
close my. Yes.
Yeah.
Yes. Thank you.
Okay, thank you, Amok.
Yes, thank you.
So for the next presentation, I would like to call Deepanvita for the paper title Optimizing Supply Chain Efficiency Using IoT, a Strategic Approach for Smart Manufacturing and Logistics. I kindly request the presenter to start with the presentation.
Thank you, ma'am. Am I audible?
Yes, you're audible.
Just give me 1 minute. Is my slide visible?
Yes, visible.
Thank you. Good morning, session chair and other paper presenters. Today, my topic is Optimizing Supply Chain Efficiency using IoT, a strategic approach for smart manufacturing and logistics. I'm Deepanita Chakraborty, Assistant Professor, Hulya Institute of Technology, presenting our study today. So, smart manufacturing and logistics rely on interconnected digital systems that enable real-time coordination, monitoring, and control across supply chain activities. IoT plays a crucial role here by improving supply chain visibility, reducing uncertainty, and enabling agile data-driven decisions across geographically dispersed networks. With increasing complexity and disruptions in global supply chains, visibility and responsiveness have become essential for operational and strategic success. By the term visibility, I like to mention here this is as per the literature available. The definition of visibility is knowing where the product is, that is, they can track the product, what condition it is in, and what is happening at each stage of the supply chain in real time. The gap of the existing literature that we could found is although IT adoption in supply chain is increasing, Existing studies provide a limited empirical insight into how IoT-enabled supply chain visibility translates into supply chain agility and in turn business performance. Most studies focus mainly on technological benefits without explaining the underlying mechanism or considering human related challenges. So, the contribution of our paper is to establish empirically the pathway through which IoT enabled supply chain visibility improves operational efficiency and supply chain agility, leading to enhanced business performance. Importantly, it also considers the role of technology anxiety, offering a more balanced and realistic understanding of IoT adoption. So the literature is available that suggests that IoT enables real-time data exchange, improves supply chain visibility and strategic decision making. And supply chain visibility can have an influence on operational efficiency and which can in turn have an impact on the business performance. This is our hypothesized research model where supply chain visibility, where we can track the product, the stakeholders of the supply chain, they can track the product and can address any challenges or issues arise anywhere in the supply chain on real time basis. So that will definitely increase. We expect that that will definitely increase, enhance the operational efficiency. But there is a glitch because the employees they are being monitored, and that can enhance their technology anxiety, and in adoption also, in technology adoption also, they can have some anxiety whether they are being able to apply it properly and correctly. So these two actually we are based on the theoretical background of BRT, behavioral reasoning theory, which actually suggests us that before we consider our performance, whenever we are judging a output, we should consider both the pros and cons. So here we are judging the pros, that is operational efficiency, and con, that is technology anxiety. So operational efficiency definitely will have a positive impact on supply chain agility, and technology anxiety will have a negative impact on supply chain agility. But once the supply chain agility is achieved, we expect that that will definitely improve, that should improve business performance. So these are the hypotheses. We are doing both the qualitative and quantitative analysis over here. We are using NVivo. What NVivo does, when we have used a structured questionnaire, open-ended and closed-end questionnaires. Now, whatever answers we are receiving from our respondents, that we have done a coding. That is, coding means whatever words they are, whatever points they are mentioning repetitively, that we will code, and we will cluster those codes under a particular uh, factor, like technology anxiety. You can see the bigger fonts means that they have used it repetitively, that's why the fonts are bigger. This is a word cloud captured by NVivo, and you can see that business performance is also there, visibility is also there. So that is actually how we reached our factors, and how then we actually made a content validity with the existing literature to get the measurement scale, because we need a specific measurement scale to measure the factors. So in quantitative analysis, we collected data. This is a our research design was cross sectional, and we used a convenience sampling method, and we interviewed 123 Indian respondents and used Likert scale to capture the responses, where 1 means strongly disagree and 5 means strongly agree. So 5-point Likert scale was used. We can see from the data that senior, middle, and lower level management guys were interviewed with experience 5 to greater than 15 years, because our study is extensively related with the operational strategies. That's why. Now, coming to the measurement model to establish the reliability and validity of the factors. So first, we can see all the 5 factors are there. First, we'll concentrate with CR. CR is the composite reliability, which measures the internal consistency of the items measuring a construct. That is, whatever variables under this constructs are there, whether they are actually measuring the factor that we are considering. And sorry, the acceptable threshold limit is 0.7, and you can see all the CR values are above that. All constructs show the strong reliability ranging from 0.881 to 0.934. Next, coming to AVE, average variance extracted. This measures the amount of variance captured by a construct relative to measurement error. The threshold limit is 0.50, and all the AVE, whatever we have calculated, you can see that are meeting the threshold limit. Next one is MSV, that is maximum shared variance. This is the highest squared correlation between a construct and any other construct, and MSV should be lower for each and every construct. MSV should be lower than AV. You can see for supply chain visibility, say MSV value is 0.171, AV is 0.715, so that is lower. That has to be lower. And ASV is average shared variance. This actually the average square correlation within other construct. So ASV is also less than AV. So these two criteria confirms the discriminant validity. We can see the diagonal values that has been kept in bold. 1 2 3 4 5 is there, 1 2 3 4 5 is there in the row also. We are actually considering the cross correlations between all the factors itself and with other factors. So diagonal values, these are actually square root of AV, and these represents the construct reliability. These diagonal values that we can see all are put in bold. These are actually represent the construct reliability compared to interconstruct correlation. We have considered here the Fornin-Lurker criteria, and all diagonal values are higher than the corresponding correlations. We can see like 2 is operational efficiency, 1 is here supply chain visibility, 2 and 1 is giving this value 0.082. This is less than the diagonal value 0.787, and it is happening everywhere. Okay, we can get some negative values as well. These are the diagonal values which are actually shows the direction and strength of relationship between constructs. So all are, we can see, within the accept limit. Next, we are considering the structural model. That is whatever hypothesis we have made already. We are testing those hypotheses. The regression coefficient beta, that is giving the slope of the regression line actually. So this is giving OE and SCVI. OE is operational efficiency and supply chain visibility is SCVI. We are getting a positive relation that we have considered, that supply chain visibility will have a positive relation with OE. That is what I have said already. And similarly, we can consider all the the regression coefficient for all the relations. We can see the regression, the beta value is the highest impact on the supply chain agility on business performance. That is what we have assumed, that this we checked actually. We checked the theory, that is supply chain agility will definitely induce business performance, and we have a very strong negative relation between supply chain agility and technology anxiety. So this needs to be taken care of whenever managers are making their strategies, that employees technology anxiety has to be reduced to achieve the supply chain agility. All are significant, we can see at 1% and 5% significance level. So therefore, we are accepting the hypothesis. Now, discussion how we can interpret the result. The findings indicate that IoT-enabled visibility improves efficiency through real-time tracking and faster decisions. However, without proper training, it can create anxiety among employees. That I have already said. While efficiency strengthens agility, technology anxiety weakens it by by slowing the adoption and coordination. And agile supply chain ultimately enhances business performance through better responsiveness, cost efficiency, risk handling, etc. Our study has both theoretical and practical implications. The study extends the behavioral reasoning theory by incorporating both positive and negative outcomes of IoT adoption in supply chain. And the practical implication is for managers. The study highlights the need to balance the technology adoption and human centric strategies so that the employee can be trained properly. They should be given user friendly interfaces so that they can effectively use IoT in supply chain and they can reduce their technology anxiety. So, in conclusion, we can say that the IoT driven supply chain visibility improves efficiency and agility, but also generates technology anxiety. A balanced techno-human framework is therefore will be essential for optimizing business performance. We have some limitations. We have used here generic constructs and we have excluded factors like firm size, cultural variations, these things. And another thing is we have used here convenience sampling, so and cross sectional data, those have limitations. Actually we have focused over here, rather than focusing on a very large data set, we have considered here, as I told you, a very small one like 123 respondents, because our objective was to focus on establish the theory, the causal relationship to establish, rather than reaching the statistical robustness. But definitely if we can get our respondents from different geographical and cultural region, from different countries, definitely that will have a impact on the data. So that is our study limitation. Thank you very much for your time and attention. I will be happy to take any question. These are my references. Thank you.
Okay, nice. It was nice presentation, ma'am.
Thank you, sir.
So there is, that the technology and supply chain management. So you are going to integrate the things for
Yes, yes, sir.
smart manufacturing and the logistics.
Right, right, sir.
Your title is that optimizing supply chain efficiency using the IoT, right?
Right, 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 right,
So
right.
Internet of Things, what different IoT devices have considered in your research, and what type of the data they are going to, that sense from it?
So actually, IoT devices, there can be some IoT devices which will capture. First, I will come to the data. Um that is, the data will be related to, as I said, that if there is any problem in the supply chain at any point of time. So
Like
then
camera,
that can,
camera. So
yes, sir.
IoT devices like different sensors that were used, because IoT is nothing but the sensors, right? That
Right, right, sir. Different sensors will be there because at a different point of supply chain, sir, there can be different type of supply chain disruptions, as you know.
okay.
So these sensors will actually catch the data, and that will be actually the decisions will be taken. These decisions will be very much centralized. But supply chain, the problem is it is not centralized. The operations are decentralized. So it is very much important that wherever there is a supply chain disruption, the data will be captured in a real time basis, so that the people who are sitting in the decision making positions, they can take the decision and that can be implemented to minimize the loss.
Any challenges that you face while implementing IoT based solution?
Definitely, sir. The major challenges regarding the training of the employees.
Okay.
Any employees, because
Hmm.
you see, sir, even in the managerial level also, uh,
Hmm.
age is a matter, sir. Sorry to say, but age is a matter. There are lack of adaptability. They don't understand how it is working. And sometimes whenever they are getting the data, even they are not being able to interpret it properly, so there are chances that they are misleading their people.
Okay, ma'am. Thank
So
you.
training is very important. Thank you so much, sir.
Okay, thank you, Dipanvita. Can you please answer your presentation?
Sure, sure, ma'am.
So for the next presentation, I would like to call Abira Bani for the paper title Personalized Travel Assistance Using Rasa, a conversational AI chatbot for tailored recommendations. I kindly request the presenter to start with the presentation.
Good morning, everyone. I guess I'm audible.
Yes, you're audible.
Yes. So I'm just kindly sharing my PPT with you all.
Yes.
So good morning, everyone. This is Abira Banik, Assistant Professor, St. John College of Engineering and Management, Maharashtra. So I'm very delighted to join you people and present my research work along with you. The topic of the presentation is a personalized travel assistance using RASA, which is a conventional AI chatbot for tailored recommendation. My paper ID is 284, and I have a few group members along with me, which is Ms. Shreya Mishra, Kundan Chaudhary, Papu Yadav, and Ramanand Raja. So, starting with my presentation, there are a few things that I would like to share my thought processes. First is regarding the travel assistance, the growing demand for the personalized tour traveling has led to the adoption of intelligent conversational agents that will assist the travelers with the itinerary creation. Like whenever we would like to travel, we would like to have a customized travel itinerary. So the proposal will help me to give me a personalized itinerary creation, which will have has a huge base of travel informations regarding the destinations and other things. So in this entire content, the main role will be played by a chatbot, which is nothing but a AI-based system that will communicate users using the NL, which is natural language to text-based conversations. Next is the thing that is what travelers often face is they struggle to plan trips efficiently because the information which is available with us is scattered across the websites, travel agencies, and the guidebooks. So the traditional methods do not provide any personalized or real-time recommendations based on whatever preferences the person may have. And it is also not physically possible by all the physical travel agents to cater all the users at one time due to resource crunch and all those things. And the existing travel platforms that we have across the website, they lack natural language interaction, which leads to the problem that we face, which is my next thing. This is the problem statement that I have found out that the rapid लोगों का thought process or to shift towards traveling and the lack of itinerary availability and information across the website has led me to design a chatbot that will help the users plan and get information about the personalized tours and much more suggested according to my own preferences regarding the destinations and other travel related services seamlessly that will decrease the human effort and that will be available in 24 into 7 at a very low cost. Motivations is as simple as that it will give me instant access to travel information, which is difficult right now, and the travel agents cannot handle many users simultaneously, physical travel agents. The objectives to build is key. I will be building the proposed methodology builds AI chatbot using a technology called as RASA, which will be giving me personalized tour recommendations. The scope of my methodology will cover Maharashtra mainly and few major Indian destinations where English language support is only given and there is no real-time booking available till yet. Much more motivation is also led to that the rapid advancement of the AI and NLP has significantly transformed my digital interactions, which has led to an increased reliance on intelligent systems for personalized recommendation. Travel planning is often a time consuming and a complex task requiring extensive research and decision making based on the individual preferences. Here's a few of my related here is a few of my related work, the few four basic base papers that I've taken into consideration, and the table
clearly shows the summarized content of the paper and the gap analysis that I have found out. The first paper gives me a gap analysis of it will only upgrade customer services and depends on social media information. The second paper that I've taken as a base paper for understanding that only concentrates on Karnataka tourism and it has linguistic barriers. The third paper is unable to find me a best deal for the hotel rooms of the flight within the budget. And the fourth paper is only designed to handle customer support inquiries. And it is sometimes unable to connect with the payment gateway to process refunds and all. And then another gap analysis that it has is the lack of connectivity that can limit the chatbot's availability to provide a solution to the whatever user recommendations it has. This is the proposed methodology that we have worked together. It says ki we are having a few of the what I would say steps that will go on. First, we had done the UI design, and then we have installed the framework and platform. We have gathered the data across the websites. We have developed a chatbot. Into that, after developing the chatbot, we have integrated that chatbot with the website. Similarly, some other parallel tasks also been done. That is testing and bug fixing that has been done. Progress tracking is also been taken into consideration, and we have trained and refined the chatbot. Next is we have optimized the website into which we have integrated the chatbot and we have updated and evolved. Next, I would like to take it into consideration the main hero of my paper, that is RASA. RASA is nothing but a open source machine learning framework that is used to build customized conversational agents. It is basically written in Python and consists primarily of two components, which is my RASA NLU, which stands for Natural Language Understanding, which will be performing my intent recognition and my entity extractions. And it also has my RASA core, which manages the dialogue flow. It will also manage my conversation states using the tracker and selects the next action, whatever is to be taken according to my dialogue policies. Another thing that is my domain file, which will be defining the structure of the chatbot, which includes intents, entities, actions, and responses. And we have the final one, that is my custom actions, that will finally execute the logic to provide a personalized travel recommendations and hotel informations. The data set and experimental setup that we have done is my data set is created largely using intent-based travel queries, and where every intent has been trained with multiple user query variations, whatever was possible into our time constraints and all. The entire data is being divided into 80-20%, which is 80% is used for my training and 20% for my testing sets, which is a standard that we maintain throughout. My chatbot has been trained using RASA NLU framework, and the performance evaluation has been done regarding F1 score. Experimental results that we have done after integrating the chatbot into the website gives me high intent recognition accuracy. Whatever intent has been given, the chatbot has understood that and given me according recommendations. This is my results and performance, where my chatbot, RASA-based chatbot, has achieved high intent classification. As you can see, the metrics that I've given, where the overall accuracy is 90.8, and my F1 score that has been achieved is 89.6. It has been demonstrated effectively that the entity extraction for the travel queries has been perfectly done. Performance is consistent across multiple query variations, and the result that I've been received after the entire process is confirms the status suitability of my RASA NLU for personalized travel chatbots. Next thing is, along with that few things that we have also done with my project is we have given the chatbot integrated website to a couple of the students that are present in my institute current. We have implemented that. We have taken response from that regarding using a Google form, where we have got a scoring of 4.3/5. because they are quite happy with the service that the chatbot is doing because they are able to understand the queries and give recommendations. We have also created a data set from them, whatever they have given as remarks. We are currently working into it. We are right now working towards covering much more states. We have a future scope of integrating data and concerns regarding international things. We're also planning towards um, getting it to the flight bookings. Still now we are only with the uh, recommendations on regarding the travel. We are going towards flight booking and train bookings. These are my future scope. Here's an use case example that I've given where the user wants to visit a place in India. Now the bot, what it does, it detects the intent, it extracts the preferences, it suggests destinations that can be taken up. It also takes up the follow-up. It suggests what is the best time to visit, what are the attractions in that particular state, what are the nearby hotel suggestions that can be given. This is all given by my chatbot. And with this, I come to the end of my presentation. Here are a few references that I've taken into consideration while building up the proposed methodology. What conclusion we can draw is the methodology that has been proposed is a promising start and also gives me possibilities that we can work on ahead. With a combination of a user-friendly interface and an intelligent AI-integrated chatbot, the trips that are planned by the travelers are now aimed to be revolutionized, making it more enjoyable and having an efficient process. The chatbot demonstrates high efficiency in providing tourism-related information, assisting users with the tour bookings and also addressing customer complaints. The chatbot also enhances user engagement and simplifies the travel planning experience. With this, I conclude my presentation. Here are a few of these future scopes I've also stated. Another thing we are right now working and I'm continuing with the project with the same group of people regarding we are trying to integrate real-time weather updates also. And also we are trying to implement voice-based introduction so that it becomes much more user-friendly. I conclude my presentation over here and I'm open for the question and answers.
Okay, thank you, Avira. So you can proceed with the questions.
Yes, ma'am. And all the presenter should follow the timeline because you are extending your presentation beyond the time limit, right? And you, ma'am, you must interrupt the presenter, okay? If you they are that going beyond the time limit, right?
Sir, I'm unable to hear you. I guess there is
Yes.
some
Yeah,
network
yeah.
glitch.
Right. My question is that, ma'am, I just want to about the security because there are a lot of AI agent chatbots are, that the developing and designing.
Sir, I'm unable to hear. I'm very sorry. I'm unable to hear you, sir.
Yeah, I am audible to you. Hello.
Yes, sir, you're audible.
Okay. Yes, I just want to ask one question regarding the security. How users' data that will be secured at your end?
We have used the concept of login and all that. So data privacy, right now we are only training and testing over the chatbot where we have maintained a data set with us right now.
Yeah, that will
But
be
we are
okay. But
working
that,
towards the security providence to the users' data also regarding their travel, whatever they have preferences. Right now, we are still not taking up the flight bookings and all. So I guess no data breach will be there. It is only the preferences they want to take regarding the travel.
okay, because sometimes the user asks their questions, where they want to go and how to go, right? So that data should be, that keep in memory. Whether you going to use the long-term
Sir, I'm
memory or the
unable to
short,
hear you, sir.
whether you are going to use that short-term memory or the long-term memory, right? So whether you are going to store that data, whatever the user asks some questions to the chatbot and chatbot
Hello.
will respond you, right?
Sir, I'm unable to hear you, sir.
Okay. Yes, ma'am. It's over. Thank you, ma'am. Take a next presentation.
Yes, sir. And I request every presenter to complete the presentation within the given time limit only. Please don't exceed that. So for the next presentation, I would like to call Rohan for the paper title Project Prithvi, a multi-agent system for geospatial intelligence and monsoon impact assessment. Kindly request the presenter to start with the presentation.
Madam, I'm very sorry. I'm unable to hear you. I guess there is some network glitch, either from my
Ma'am, it's
end or
okay.
your.
Your presentation is over. Can you please unshare your presentation?
Yes, madam, for sure.
Rohan, you can start with your presentation.
Hello, am I audible?
Yes, you're audible.
Okay. Is the screen visible?
Yes.
Okay, so good morning, everyone. Myself, Rohan Joshi, and alongside Aditya Mandorgi, under the guidance of Dr. Parikshit Mahalle, we have developed Project Prithvi, a multi-agent system for geospatial intelligence and monsoon impact assessment. It is extremely crucial to understand that Indian monsoon is a primary driver in India's economy. 75% of annual rainfall occurs in a span of 4 months, where 1.4 billion people directly or indirectly depend upon it for their survival. It affects the sectors of agriculture, trade, finance, and directly or indirectly every individual. Agriculture contributes to 18% of our total India's GDP, where 51% of our farmers depend upon this red-fed agriculture. The problem currently is not that there is not any data. Monsoon data is present widespread, but the issue is that data which is present is fragmented in nature. It is divided in government reports, satellite-based data, or ground station-based data. Therefore, there is no unified analysis present. At the same time, indices which are traditional in nature, they are either single variable or linear combination based. Interpretability of these particular indices can be done with the help of deep learning models, but these models are black boxes, therefore, policy critical decisions cannot be taken on the basis of these. It leads to operational failure wherever critical situations arise. So, this is a representation of the current scale in India. There are climate resilient solutions which are extremely required based upon the current context. So, what are the indices which our government uses? So, there is SPI, which is used to represent rainfall. It is able to see the precipitation, however, soil moisture or actual impact of it on crop is invisible. VHI, which is used for vegetation, is used to represent surface greenness, but it is not able to mention early stress signals which are present. Both of them result in 710 false alarms or 390 missed droughts, respectively. NDVI, which is used for the measuring of canopy, has a lag time of 3 to 4 weeks because readings are durated at that particular point of time. We have TCI for temperature and SMAP readings, which are soil-based readings that are used on a pixel range of 9 kilometers range. So what is the solution? You know that there are all these particular indices. What if I was able to explain every single index with the help of just one particular number? This number is the Monsoon Health Index, which is a major creation in the terms of agentic system. We have created it by using economic chemical distributive function based transformation. So every particular range that was present, we converted it to into a percentile in order to bring all the different indices of different units on a similar scale. Then, when these particular units were on similar scale, we identified their particular weight to understand which indicator or which particular value has more impact on it. And then on the basis of it, we created the MHIZ by the process of calculating the eigenvector. This MHIZ is now a single value, which is able to represent your actual verdict of whatever the particular situation or the scale is. This leads us to the actual solution, Project Prithvi. As we know, multi-agent systems are able to develop and able to understand and automate tasks to a greater extent. Project Prithvi consists of three particular agents. It consists of a data interpretation agent, an analytics agent, and a retrieval agent. The analytics agent is able to access the data from the satellites. It is able to create and store this particular data in PostgreSQL and the archive files in Amazon S3. At the same time, the context retrieval agent is able to fetch these external contexts, which is news adversaries, government reports, and social media representations, actual data that is present from CWWG reports. And all this evidence that is present is stored in a vector database. At the same time, the analytics agent is able to create your MHI index and create the particular forecasting pipeline. Both of these are then transferring their data to the data interpretation agent. So whenever a user asks a query, the interpretation agent breaks down and calls the respective agents. And as a final result, you are able to see the actual representative index value, the contextual explanation of it, and at the same time, what is the actual condition in the country. This is a representation of the process flow that is present in Prithvi, where we are moving from data ingestion to actual application and decision. There are three particular agents which can be justified as analytics agent has computation and therefore it is heavy in terms of it. Context agent has a basic task of retrieval and therefore it is RAM heavy. Separating these particular tasks allow us to scale them individually and differentiate their responsibilities efficiently. You can also see a breakdown of the data flow that is present. And this is a representation of the tech stack that is used. The core system that is present is deployed on AWS, where the actual archive files are stored in S3 and the recent data files are stored in PostgreSQL. We are coordinating and ingesting our particular processing pipelines with the help of AWS Glue. And the entire agentic system services that are present, including the Claude 3.5 Sonnet LLM or the Titan V2, which we use for the process of embeddings, both of them are their source from Amazon Bedrock. At the same time, a secure API gateway is exposing our particular system. Vector database is used for AWS OpenSearch. And AWS Lambda, which is used for Lambda Sentinel, is a timeline that runs every particular 5 minutes to pull IMD and News API calls to ensure that we are constantly updated in that particular loop. The centralized logging is done with the help of CloudWatch. And this is a general representation of the network and the cloud structure that has been developed. In order to ensure that the entire system is secure, we have developed a virtual private cloud in Amazon itself with the subnetting structure, where public subnetting, private app subnet, and data subnets have been hierarchically arranged inside each other. For the process of testing and validation, we created a 10-year baseline. It consisted of understanding the particular baseline values of these three indices, then converting and creating their particular MHI. At the same time, to label and validate, we created drought reports and understood their particular labels. On the basis of this, we created a particular calculation of how this MHI, in comparison with its respective other indicators, is covering the domains that are present and what is its linear association with that particular target value, where we have a Pearson correlation value of 0.78, which was far more superior than its competitors. At the same time, in terms of understanding and detection of a particular drought, we considered a threshold to understand what particular value beyond it can be explained. MHIZ was able to efficiently explain both the constraint that was present in terms of SPI as well as VHI in terms of its actual representation. And then, as I mentioned before, we derived weights to understand which variable has what more percentage. So precipitation was the dominating factor. Soil moisture became the second dominating factor, and vegetation, since it is actually based upon a lag-based timeline, it consisted of 0.36. This is a representation of the actual baseline that is created. And coming to the last part of the presentation. So what is actually going to happen? If you are a particular user, you will be answering a particular, you will be querying a particular question to the interface that is present. Let us say that you state that, okay, this is a particular dilemma that is happening. Actual case study was that in October 2018 in Marathwada, the region of Maharashtra, policymakers faced a contradictory signal. On the government website, the SPI stated a value of minus 1.7, which states that this is a condition of severe drought. But at the same time, the VHI index stated that no, everything is quite normal, as you can see in the images that are present. Now, if we have to manually resolve this particular issue, it will take a timeline of 3 to 6 weeks. What do we do? The agentic resolution has a data ingestion of satellite-based data. All these individual indices then work together and in that particular understanding, we were able to see that, okay, Soil moisture is down to its fifth percentile, meaning the actual condition is that soil doesn't have a certain amount of moisture that is present, and because of that, drought conditions are there. Since rainfall was present in earlier times, it was able to not represent it actually. And same at the time, qualitative validation was able to retrieve these local government memos and vernacular news. At the end, we had a synthesized verdict which was confirming that actually there is a particular case of extreme drought, and thus we are actually moving towards an actual implementational based solution. This is a sequence diagram representation of the same process that I mentioned. All the tasks that are present for both the agent, they run parallelly in order to ensure maximum efficiency. And this particular entire system was the actual development of Prithvi. The interface over here is nothing but a representation of analytics dashboard, a geospatial map, and the actual range values that are present. I would like to end my presentation by stating that in our particular age of modern rapid systems, it is important to understand the data, but at the same time, it is also important to provide a proper discrepancy analysis of it. That's it. Thank you.
Sir, you can proceed with the questions.
Yes, it was the nice presentation, and all the slides were self-explanatory. And I think that there will be no questions from actually from my side because everything that we have covered. Just I want to ask you the result analysis or the accuracy of this system. Have you validated?
Yes, sir. So actually, when we are talking about result analysis, since we are considering the entire system and the actual working, this particular system was able to explain what is the actual ground truth situation to a greater extent compared to these indices that are present. Currently in India, we don't have any particular multi-agent system which is targeted for this particular approach. Now, when we are considering this system, the core thing that is happening inside it is the MHI index that is present. So the first idea that we thought was that we had to first explain this MHI index and then try to validate it. Now, when we are trying to validate it, since domains are precipitation, that is rain, soil moisture, and vegetation, first we tried to find what is its direct correlation and how is it able to explain it. At the same time, how much variance it is causing. For that particular purpose, we used our first test. Then in a drought event detection, we considered a threshold key. Okay, 1.5 minus 1.5, if it goes behind it, then it is a particular case of drought. And then government reports were taken. On the basis of these particular government reports, we created those labels and then we cross-compared it, where precision and recall scores of our index was also good. And since these particular validations are present and the agent's core itself is this particular index, we were able to validate the entire agentic process.
Total, how many agents that were used in your system?
There are three agents in total. There is
Okay.
an interpretation agent, which
Okay.
will understand the query, break it down. The query
Okay.
passes on to two agents, which is the analytics agent and context agent. Analytics agent handles
Yes.
everything of computation.
Okay. Okay.
And
Yes. Got it. Got it. Yeah. Thank you.
yeah.
Okay, thank you, Rohan. Can you please unshare your presentation? Okay, for the next presentation, I will like to call Aditya for the paper title Smart HydroSense IoT based ESP32 system for continuous water quality assessment. You can start with your presentation.
Hello, am I audible?
Yes, you're audible.
Yeah. So, good morning, everybody. I am Aditya Deshpande from KLE Technological University, Hubli. Our project title is Smart HydroSense IoT-based ESP32 system for continuous water quality assessment. So, when we talk about the introduction, water is one of the most critical resources on Earth, and its quality is vital for health, agriculture, and industry. Monitoring water involves measuring parameters that include chemical, physical, and biological quality. So, the parameters which we have focused in the project are namely turbidity, which tells us the cloudliness or due to suspended particles like salt, clay, and microorganisms. High turbidity can reduce water clarity and indicate contamination. And the next is pH, which tells us whether the water is acidic or alkaline. Out of range pH can be harmful to humans' health and ecosystem. And when we talk about TDS, the total dissolved solids, the concentration of dissolved salts, minerals, and metals. High TDS can indicate water contamination or high salinity. And when we talk about temperature, influences chemical reactions, biological activity, and sensor accuracy. So these are the papers which we have went through, and uh, these are the papers which we have went through, and the outcomes from these were like many projects have been based on the labor based measures, take times and expensive equipments. Manual sampling is labor intensive and cannot provide real time for contamination. So what our problem statement basically is, rural and remote areas often lack access to continuous water monitoring. Contaminated water consumption can lead to waterborne diseases like cholera, dysentery, and diarrhea. Conventional methods are slow and expensive, delayed detection and intervention. There's a need for low cost, energy efficient, autonomous system that can provide real time water quality monitoring. So when we talk about the consequences without real time monitoring, delayed detection of water contamination happens, and there will be a poor decision making in agriculture and industrial field, increased risk to human health. So coming to the objectives of the project, real-time measurement, like continuous measurement, measure turbidity, pH, TDS, and temperature, continuous monitoring and alerts, trigger alerts if any parameters crosses safe thresholds, low cost and energy efficient, affordable hardware, and solar powered. Accessibility, probably deployable in urban and rural areas, data visualization, trends of water quality parameters displayed on cloud dashboard. Scalability, system can be expanded with AI for prediction of water quality trends. Now when we talk about the functional block diagrams, here's a step by step. So first comes the sensors, which collect the physical and chemical water quality parameters, convert them into electrical signals. And when we talk about the microcontroller, which is ESP32, works as the brain, processes signals from the sensors, processes raw data and converts it into the units, compares with predefined safe ranges, send procedure data to the cloud platforms, and updates local displays such as LED. And further comes the cloud platforms where the data are stored, displayed in the forms of graph and visual dashboard, sends alerts to the mobile devices or the dashboard when the readings exceeds the safe limits. So when we talk about power systems, we have used solar panels that charges the battery. Battery powers ESP32 and sensors continuously, ensuring system works even at night or cloudy days. So this is basically the circuit diagram. The sensors are connected to the microcontroller, and we have an LED. We have an LCD for the display. Yeah, and this is basically our model which we have worked on. Yeah, is the model visible to you all? Hello.
Yes, it's visible.
Yeah, okay. So when we talk about the tools and component we have used, so first comes the ESP32. As mentioned earlier, it's the central processing unit of the system, collects the data and transfers it into the units and sends data to the cloud via Wi-Fi, and then the further LCD is displayed. Key features of ESP32 are basically dual core processor, built-in Wi-Fi and Bluetooth, multiple analog and digital input output pins. Yeah, and when we talk about the other hardware components, there are several sensors that come into our play. pH sensors measures acidity and alkalinity of water, and the safe pH range is around the safe pH is around 6.5 to 8.5. And when we talk about the hardware integration, the analog output is transferred into ESP32 ADC pin, and then the threshold, then the device compares it with threshold, and the alerts are triggered. So the next sensor is TDS sensor. The safe range for TDS sensor is 0 to 500 ppm as per the guidelines of World Health Organization. So again, the same software function is to send the data to the cloud and trigger alerts if needed on the dashboard. And the next sensor is temperature sensor. So when we talk about the safe range of temperature sensor, it's basically 0 to 35 degrees Celsius. And in the hardware integration of the temperature sensor, the digital pin is directly sent into ESP32 I wire input, and the temperature is being displayed on the LCD. So the next part of the hardware component is basically the display, where real-time readings are shown. And the solar panel also comes into hardware component, so provides autonomous and renewable energy to our project. When we talk about software components, Arduino IDE is program environment for ESP32. Sensor calibration and data reading are its task. And when we talk about the future features of the Arduino, supports library for all sensors. When we talk about cloud platform, we have used ThinkSpeak, stores real-time sensor data, visualizes parameters via graph and dashboards, sends alerts if needed. Yeah, and these are actually the same thing. So when we talk about the proposed methodology, connects all sensors to ESP32 with correct and analog and digital pins, include voltage dividers, pull-ups, and resistors where needed. And then further sensor calibration, pH. When we talk about pH, use standard buffer solutions. When we talk about TDS, use known conductivity solutions. When we talk about turbidity, use NTU calibration standards. The next step is firmware development. Read raw sensor values, convert voltage counts to physical units, apply
Sorry
threshold.
for the interruption, but you only have 1 minute left to complete the presentation.
Okay. Yeah, I'm about to end it. Okay, so firmware development, apply threshold and logic to trigger alerts. Then next comes this cloud data transmission. ESP32 connects to Wi-Fi, sends reading using HTTP post, data stored in ThinkSpeak. And when we talk about the next step, visualization and alert, dashboard displays the real-time trends and sends alerts when needed. Power management is through the solar panels. And when we talk about the testing and validation, compare sensor reading with laboratory measurements, optimize calibration and code for accuracy. Yeah, thank you. I completed my presentation and open for the question and answers.
My question is there, ki what is the novelty in this work? Because you know that ESP32 microcontroller and IoT sensors collecting the data and analysis. So what is actually the novelty in your research methodology?
Can you repeat the question?
This is a generalized key ESP32 that will be used, you know, that the controller,
Yes.
microcontroller, and all the sensor that would be used to check the taste the quality of the water, right?
Yes.
So what would be the any new thing that you have added in your work?
Yes, sir. The novelty of my project lies in the integration of ESP32 based IoT system for real-time water monitoring with remote accessibility and alert mechanisms, making the system more smart and low cost. Use of ESP32 instead of conventional controllers. Like ESP32 has an inbuilt Wi-Fi, reducing external hardware cost and power consumption compared to Arduino plus Wi-Fi modules.
Okay. Thank you.
Okay, thank you, sir.
Okay, thank you, Aditya. Can you please ensure your presentation?
Yes.
So for the next presentation, I like to call Shruti for the paper title, Smart Traffic Light with Real-Time Ambulance Detection. I kindly request the presenter to start with the presentation. Shruti, are you there in the meet?
Hello.
Yes, you're audible. You can start with the presentation.
Yeah, actually, there's one more co-author with me. Is it okay if we both present, or should I just present it alone?
You can present. But please be quick. We're already running beyond the time. So, possible.
Okay. Yeah, yeah. So I would request Ruchi to start.
Yes. Am I audible?
Yes.
So these are the contents of the PPT. Okay. Introduction. The smart traffic light with real-time ambulance detection system is designed to reduce delays faced by ambulances in heavy traffic. Conventional traffic signals operate on fixed timers, often slowing emergency response. So this system uses sensors, RFID or RF transmitters to detect the ambulance approaching at intersection and automatically turns the signal green in their direction, creating a green corridor for smooth movement. After the ambulance passes, the traffic light returns to its normal sequence, minimizing delay and manual control. So the model operates two smart sensors and communication models installed at intersections which are capable of recognizing ambulance, sirens, or light patterns in real time. It ensures faster emergency response, reduces accidents, and improves traffic flow. Next is the problem statement. So, emergency vehicles, particularly the ambulances, are often delayed in congested urban traffic due to conventional fixed timer traffic signal systems, leading to critical losses in response time and increased risk to human life. Then, the objectives. So, the main objective of this system is to improve ambulance movement in traffic by using smart technology. It detects ambulances in real time using sensors, RF, RFID, or AI based methods and automatically gives them priority at traffic signals. By dynamically changing the traffic lights, the system creates a green corridor at intersections, allowing the ambulance to move smoothly without stopping. So, this greatly reduces emergency response time and helps save lives. Since the process is fully automated, it minimizes the need for human intervention by traffic police. Next is the literature survey. So, overall, we have viewed 14 papers. So, the first is in which the paper is relevant as it shows how fuzzy logic and AI can be used to prioritize emergency vehicles which support intelligent decision making in traffic signals. Second, this study supports the project by using real-time embedded system to reduce delay and ensure safe and faster ambulance movement. In third paper, this work is closely related as it uses IoT-based centralized control similar to the proposed system for smart city traffic management. And fourth, this paper demonstrates RF-based ambulance detection, which is useful for understanding low-cost detection methods for short-range communication. Then in fifth paper, this study supports the idea of dynamic signal prioritization based on urgency, which aligns with ambulance priority handling in the project. In sixth one, this paper is relevant for understanding route optimization and multi-junction coordination, important for creating a continuous green corridor. Seventh, this work shows how microcontrollers like Arduino can be used for ambulance parity, proving the feasibility of low-cost hardware implementation. In 8, this paper supports the project by explaining AI-based siren detection useful when RF or RFID is not available. In ninth, this study demonstrates adaptive signal control using various traffic density, which helps improve system efficiency and intent. This paper is relevant as it focuses on collision preventing during signal prioritization, improving the road safety. In 11th paper, this work shows that ML models can detect sirens with small dataset useful for practical and scalable deployment. In 12th, this paper supports real-time audio-based detection, which improves reliability in noisy urban environments. In 13th, it provides a foundation for deep learning-based siren recognition, contributing to intelligent detection methods. And in 14th, paper highlights basic sensor-based traffic control, showing the limitations of traditional system and the need for smarter solutions. Then is the research gap. So many existing smart traffic systems use technologies such as RF modules, IoT, fuzzy logic, or AI-based siren detection to give priority to the ambulances. However, these methods have several limitations. RF-based systems often suffer from limited range and signal interface, especially in crowded urban areas. On the other hand, audio-based AI systems can fail due to high background noise, such as honking, construction sounds, or heavy traffic.
Okay, so for the proposed system, our proposed system uses a hybrid detection architecture. That is, it uses RF detection as well as a siren sound recognition model. Each ambulance will be fitted with a 433 megahertz RF transmitter, which will only transmit a signal when the siren of the ambulance will be turned on. And at the traffic junction module, RF receiver will be connected, which will continuously monitor from any signal from the transmitter. In parallel, at the traffic junction, MEMS INMP 441 microphone will also be connected. Will also be connected. The main core of the traffic signal module is the ESP32 microcontroller. We have used this microcontroller because it has the ability to run the ML model as well as perform many other functions like control the traffic signal lights as well as process both the signals that it receives. The TinyML based siren recognition model will confirm the presence of the ambulance. So when the input will be received at the microphone, it will be sent to the model will be reviewing it and will confirm that it is a siren sound. When both the inputs are verified, when both the inputs are verified, a green corridor will be provided for the ambulance, that is the lane in which it is present, as well as a message will be given out on the LCD display that an ambulance is detected. The remaining lanes will continue the normal traffic signal functioning, and the green corridor will be provided only for the ambulance lane. Okay, so this is the block diagram of the system. The core ESP32, transmitter on the ambulance, receiver on the traffic signal unit, as well as a microphone. Both inputs will be reviewed and a message will be given out, as well as green corridor will be provided. For the methodology and the lane prioritization, we have used a logic table for the prioritization of the lane ambulance. We have used two inputs, RF input and sound input. So in the table, we have included four lanes, lane A, B, C, and D. And we have ensured that even if one of the input is verified, the lane will be turned into a green corridor immediately. So in case one lane detects an emergency, that lane will be immediately provided a green corridor. In case two of them are detecting an emergency, both of them will be given a green corridor, while the rest will be strictly red to ensure that they safely commute and there is no restriction in their path. If all the inputs are active, there will be an emergency override mode. This methodology and this
Sorry
prioritization.
for the interruption, but you only have 1 minute to complete the presentation.
Okay, yeah. So this methodology will ensure fairness and safety of the system. So for the flow chart, this begins with the ambulance that will transmit a signal. When the siren is on, the receiver will receive it, as well as the siren sound, which will be detected by the model running on the ESP32. Both will be reviewed, and the presence of the ambulance will be confirmed, and false triggers will be avoided due to this method. Then a green corridor will be provided, as well as a signal will be displayed. This is the flow chart that we have used. For the results and discussion, we are expecting a detection accuracy of around 80 to 85% and a response time of 3 to 5 seconds, ensuring minimal delay. It consumes low power, that is approximately 2 to 3 watts, making it energy efficient. This system demonstrates moderate to high reliability under realistic traffic conditions and can be integrated with existing traffic infrastructure without major modifications. So for our future scope, we are planning for a GPS integration, which will help to track the precise location of the ambulance, as well as IoT connectivity, which will allow real-time communication between different ambulances. We are also planning a cloud and mobile integration so that it will support live alerts, as well as people will be individually able to get alerts about the ambulance, as well as automated traffic management and to reduce human intervention and automating while contributing to smart traffic management. So the conclusion is this work presents a smart and intelligent traffic light system for real-time ambulance prioritization. By combining RF communication and ML-based siren detection, and lane-aware control logic, the system will significantly reduce ambulance delay and improve emergency response efficiency. This solution is cost-effective, scalable, and adaptable, and can be adapted to existing traffic control systems to reduce ambulance delay and improve emergency response efficiency. These are the references that we have used. Thank you.
Okay. I would like to ask one question. If there is a car with ambulance siren, uh, actually, which is not an ambulance, but which is having a siren of that ambulance, so how it would be detected?
Sir, actually, in our future scope, we are planning to integrate a camera as well, so that there be a more accurate detection of an ambulance.
Okay.
So the siren sound will not be a restriction in that case.
Because that will make a full to the system, right? Hmm. Yeah. So this is your future scope, right?
Yes.
Okay. Okay. Thank you.
Thank you.
Thank you, Shruti and Ruchi. Can you please have your presentation? So for the next presentation, I would like to call Gulf for the paper Agentic AI in Enhancing Cyber Resilience in the Global Financial Environment. I kindly request the presenter to start with the presentation.
Yes. Hi. Good morning, everyone. My co-author will present this presentation. So, good morning, everyone. Today, I'll be presenting our work on agentic AI for cyber resilience in financial security. So, the core idea behind this research is a shift from reactive cybersecurity systems to autonomous self-learning cyber resilience frameworks. Financial institutions today face zero-day attacks, AI-driven fraud, and highly adaptive adversaries. So our work proposes a novel agentic AI framework built using Crew AI and large language models that can reason, act, and learn autonomously to protect financial systems. So here's how the presentation is structured. First, I'll walk through the architectural framework of our system. Then I'll explain the methodology and workflow that enable autonomous threat handling. After that, we'll briefly compare our approach with existing industry solutions, followed by the experimental setup and results. Finally, I'll conclude with key strategic insights and what this means for the future of cybersecurity leadership in financial institutions. So this slide shows the core architecture of our agentic AI system. At the center is the agentic AI core powered by Creo AI and large language models, which act as the reasoning engine. And at the network boundary, we have the dynamic firewall responsible for filtering known threats in real time. If a threat is unfamiliar, it is redirected into deception intelligence, specifically honeypots, where attacker behavior can be observed safely. And finally, the cognitive feedback loop converts zero-day attacks into learned security rules. And this loop ensures that every attack strengthens the system, enabling continuous autonomous evolution. So this slide explains how the system works step by step. First, we perform data ingestion using large cybersecurity attack data sets to identify intrusion patterns. Next, adaptive filtering blocks known threats directly at the firewall level. And unknown threats are escalated to agentic threat reasoning, where the AI autonomously analyzes severity, intent, and mitigation strategy. And finally, through cognitive learning, the system updates itself so that future occurrences of the same attack are blocked instantly. And this workflow transforms cybersecurity from static defense into a self-improving resilience cycle. So here we compare our approach with existing industry leaders. Part, just to clarify your doubt, Gargi Shirsagar is a co-author who is presenting the presentation. And here we compare our approach with existing industry leaders. Solutions like Darktrace, AirGap, BlackBerry Silence, and IBM QRadar are powerful but largely fragmented. And most rely on isolated tools, limited feedback loops, or heavy human intervention. And our framework addresses these gaps by offering threat-specific architecture, unified reasoning and response, and continuous learning through feedback loops. And this is what gives our approach a distinct competitive advantage. And to validate our framework, we conducted experiments using cybersecurity samples representing diverse attack patterns. We ran two simulations. So in the initial run, a reactive baseline representing traditional security without AI intervention. And in the run two, our proposed adaptive CAI system. We deliberately focused on open source tools, ensuring low operational cost and high scalability, which is critical for real world financial adoption. So this slide highlights the measurable improvements. And what we observed was 18.2% increase in firewall level threat blocking and 22.2% reduction in AI agent workload, meaning fewer false escalations, and near zero system response time for learned threats. This demonstrates a shift from delayed reactive mitigation to preventive real-time security enforcement. So the key takeaway from this research is a paradigm shift. Agentic AI is not just a tool, it becomes an autonomous operator within security operations centers. Cognitive feedback loops eliminate the need for constant manual rule updates, and by leveraging open source frameworks, we ensure that advanced cybersecurity is cost effective and accessible, not limited to large enterprises. So to conclude this presentation, demonstrates how agentic AI, powered by autonomous reasoning, adaptive learning, and deception intelligence, can fundamentally transform cybersecurity in the global financial sector. And instead of merely responding to attacks, systems can now learn from them, evolve, and prevent future incidents automatically. And this marks a critical step towards building the future of cyber resilience, which would be faster, smarter, and self-evolving. Yes, thank you so much.
Thank you, Gaurav. Sir, you can proceed with the questions.
Yes. Yeah, it was yeah, nice presentation and a nice topic that is agentic AI in cyber security. One question is there ki how we can prevent our system from the agents, other agents which can attack on our system. So the war between agent to agent. So how we can validate our agent is that a legal one or anything else.
Hello.
Hello, I am audible.
So,
Hello.
yes, yes,
Yes, sir, you're
sorry.
audible.
For this, we mitigate agent to agent attacks. So basically, whenever an agent would be attacking, we would be isolating the agents via sandboxing and enforcing that strict role-based permissions are given, and validating that inter-agent messages are we have also validated inter-agent messages. So whenever an attack is occurred, so it is validated initially, and as shown in the architecture, continuous it is being continuously monitored, and for any anomalous agent behavior with audit logs, and it is being validated, and also for with our agentic AI architecture, human override is also possible for high risk actions. So if an agentic AI is being used to uh, like get through any system, so accordingly human override is also possible for checking for the anomalies.
Because we need to identify whether it is authentic agent or unauthorized agent.
That's right.
Right. So once we identified it, yes, it is authorized agent and doing autonomously work, then it's fine. And if it is not authorized agent, so it will work like intruder, right?
Correct. Yes.
Unauthorized access. So we need to identify it is a authorized agent and legal one, so that it will allow to work to monitor the things and work autonomously.
Absolutely. And so for for now, we have kept human intervention as well. But eventually, when we get more reliable data sets and more reliable sources, we can input that and avoid the human intervention as well in the future.
Thank you. Thank you, sir.
Yes. Thank you.
Okay, thank you, Gav. Can you please unshare your presentation? Okay. Now let's move on to our closing remark. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during this 10th version and all the previous 9 versions of conference. We will be happy to have you in 11th version, that's in 2027. All the presenter will be getting the digital certificate through email within the 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom. I also thank our session chair, Dr. Sopan Talekar, for chairing the session, a token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable present. Would you like to address the participants, sir?
Yes, yes. Yeah. I have gone through all the 10 sessions which given to me, including the IoT, smart chain, then the Prithvi, it was one of the best one, then smart traffic light with real-time ambulance detection. Almost all the presentations were good, and which included the interesting and useful presentations on the current and the real time or real world problems. And this paper showed the good ideas, practical approaches, and clear understanding of the topics. So I thank to all the presenters for their efforts, and all the audience. So through which, yes, you can connect to the different participants and their research. So thank you for giving me an opportunity. So thanks once again.
Thank you, sir, for your motivational words. Now I request everyone to switch on the camera for a quick snapshot. Okay, thank you, everyone.